Alright, this is a video for IB Physics to hopefully explain the process of how we crunch the numbers for an IA using Logger Pro. So the experiment we're going to be dealing with is the first experiment to teach you the process. This one here that you had where you're changing the length of a pendulum and measuring the period. And the goal here is to find acceleration due to gravity. So I'll show you the end goal, and then we'll go through the process. Here's the end goal. This is a 4-page document where this is part of your report. You would have the background and planning and method sections all before this. So this is just the analysis section, where you start with your data, you do some averages and uncertainties, then you explain that. You do a graph, we'll explain how to make that graph. Then you do some more manipulation, you linearize it, and you find some more uncertainties, and you explain some stuff, and then you make a graph like this that has 3 lines. And then, eventually, you get down to your equation. All right? So, almost all of this is done in Logger Pro. So, this is how it looks in Logger Pro. So, that's the first graph that I'll show you how to make. And then here's the second graph that I'll show you how to make. And the data table that makes that is quite wide. All right? So what we would start with is just this. This is just your raw data. This is times for 5 swings and the length of the pendulum. So the first thing you would probably do from this is put in a new column, calculated column, and that would be your average T, which most people will just call T, and the units are in seconds. The equation for this, you do have to slowly type out how to make an average of these 5 different trials. And remember to then divide by 5 so you get a single period. Now what I have on this file is all the formulas that I know I'm going to use. So have a screenshot of this. And that is what I would put in here. Now you'd have to type that in bit by bit. How you would do that, just to let you know, is you use the drop down menu and you want the first one plus the second trial plus the third trial plus the fourth trial. It's really annoying to actually tell it how to do an average, and then close the brackets, divide by 5 because there were 5 trials, and then we also need to divide by 5 again to get a single period. You click done, now you have that. So you're almost ready to put your first graph on, but you need uncertainties, you need error bars. So the length has the uncertainty. If you double click, it's in the options, and I've put in the uncertainty, you tick that little box, of 0.002, which is 2 millimeters. All right, there's an explanation of why. Then that's really important. You explain why these 2 millimeters are on each and every L. Basically, it's because you're estimating where the center of mass is and the beginning of the measurement itself. Here, for the averages, we're going to need to find the maximum of the trials and the minimum of the trials, and we're going to have to subtract that and take half. And what it looks like in the report is... And what it looks like in the report is the second bullet point here, where you're going to find the maximum and minimum, then half that, there's half the range. You're going to divide by 5 because of the 5 periods in this experiment. If you did 10 periods, you would divide by 10. Okay? So that in Logger Pro is a bit tricky, because the first thing you have to do is find the maximum of all this. Now, you could just look at them and decide of those 5 values which is the biggest and which is the smallest. But Logger Pro can do this for you if you wish. You need a new calculated column, and I'll just call it max, and I won't have anything there, and it has the units of seconds. And the formula that this is, it's what they call a nested formula, which is down here at the end of my notes. Here's my nested formula. It looks quite crazy because Logger Pro can only find the biggest of 2 neighboring columns. So it takes a while, But if you have a look at it, it looks at trial 4 and trial 5 first, finds the biggest, then looks at trial 3, finds the biggest of that, then looks at trial 2, finds the biggest of that, and finally looks at trial 1 and finds the biggest of that. And that comes out, once you have all of this, everything in quotes is the title of your column, to those blue numbers there. So those blue numbers there are just telling me the biggest number is 3.37, or the bottom one, the biggest number is 7.07. Similarly, you can have a Logger Pro find the minimum values, new calculated column, we'll call it minimum, no short name needed, it's in seconds. And the equation for Logger Pro is here. If you have 5 columns of data, you need to have 4 nested formulas. And it would be the green numbers. Now they have one too many decimal places. To change the decimal places, it's really simple. You double click, you go to options, and you can change the number of decimal places just like that. And I'll do it here too. Change the number of decimal places to 2. So at least it's logical. Okay, so the reason we have the max and min is because we need to subtract it, divide by 2, and then divide by 5 to get the uncertainty for each of those red numbers. So how this works in Logger Pro is you need a new calculated column, and this we can call the uncertainty of the average t. No short name needed, it's going to be in seconds. So this, with brackets, you just select your max, you subtract your min, you select your min, you close your brackets, you divide by 2. That's half your range. You also have to divide by the number of swings. In my case, divide by 5. Now you have those. These need to be rounded to 1 sig fig. All right? Even though the graphing software will use the whole number, for our tables in our report, we need 1 sig fig for uncertainties. So you double click on this again, and you tell it you want 1 sig fig, just like that. Okay. Now we're ready for a graph. If you don't already have a graph running, so you want to insert a new graph, you want the average t, you don't need a dot to dot. How to turn off the dot to dot? You can actually turn this off, connect points right here. That's how you turn off the dot to dot. Then for your axis options, on your y-axis, that's all good. So now it's just those. It hasn't put on my vertical error bars. If you go back into your average t settings and you go into options, you can tell it that your error bars are a custom column that we have right here. So that is the custom column of the uncertainty of the t average. Okay, so it's sort of buried in the text there. And then when you go back to your graph, it's now put on your vertical and your horizontal error bars. It's zoomed way into the graph. And personally, I would start it at 0 so that at least you can see that it starts with the origin. Now, this is a power curve. It won't be a straight line. The reason it won't be a straight line is it's buried in this formula here. So you can either do a t squared with everything working, or you can do a square root of L. But what I'll do, since we're graphing t and L, is it should have a power, the L should have a power of 0.5, because it's a square root, and the 2 pi over g, if you plug in your values, is actually just a smidge over 2. So what we do is we're going to fit a power curve to this. You click on this little one here, you click on the power curve, there it is, you try your fit. It's close to 2, but you want to actually change that to say, no, it should be 2. All right, technically 2.006, because that's 2 pi over square root of g in this one. And the b is the power, and you should actually have a power of exactly 0.5, because that's a square root of length. So then if you click OK, that's the theoretical relationship, which doesn't go through each and every set of error bars, but goes through most of them, and now you have something to talk about in your evaluation. So there's how you make your first graph. Okay? Your second graph, going back to our plan, that's how you make the first one right there. The second graph, we will need to square all of our t's and find the uncertainty for each and every squared t. And we're going to make this graph where you have the average t squared and the length. So in Logger Pro, here we go. We'll slide this graph off to the side, shrink it down. We don't need that anymore. What we do need, though, is a new column. Insert data. There we go. New calculated column. This one we're going to go with average t squared. Short name is just going to be t squared. And the units are seconds squared. And all we need is the average t and square it, just like that. So the purple numbers are your average t squared. We're going to need each and every uncertainty for all those purple numbers. Now that comes from the uncertainty on the average t. And the logic of this is explained in the first bullet point, where you have the uncertainty of each average, divided by the average, make it a percentage basically, multiplied by the value of t squared, then you're multiplying by 2. The reason you're multiplying by 2 is just the power on the t squared, so it's called the power rule. If you were doing a square root, you'd multiply by a half. If you're doing a cube, you multiply by 3. But here we're doing t squared, so we multiply by 2. All right? And down here you have a sample calculation for the last data point in our table. So how you do this in Logger Pro is you insert another calculated column, and you want this to be the uncertainty on your t squared values. And it's going to have the units of seconds squared. So we want the uncertainty of the average divided by the average, multiply, that's the thing above the 8, multiply with the squared value, and then multiply, the little asterisk above the 8, by 2. So, those red numbers are how good each of the purple numbers are. Yet again, uncertainties need 1 sig fig. So you go into here and you change it to sig figs, and that's 1 sig fig in the options for each column. And you also want the decimals to pair up. So in the purple numbers, you want the same number of decimal places as the red numbers. So luckily, they're all 2, so that's easy to do. So you can just change that to 2. If they weren't, you'd have to slowly change them by hand, which I'd done in my Word document. Anyway, now we're ready to do our last graph. So we want to insert a graph, and you want length on the bottom. You don't want this. You want t squared. You just want the average t squared. You want this. Now, yet again, it hasn't put on my vertical error bars because I haven't told Logger Pro what the error bars are for my purple numbers. So if I double click on this, I can go into options, click on error bars, use the column that I just made called uncertainty of t squared. And now, if I pull this back, here's my graph. Make it as big as you possibly can, and you have all of these little purple error bars. Okay? Now we're going to have to put 3 lines onto this. I'm going to leave it where 0 is not included. It's zoomed in, nice and tight. Okay? So the line of best fit's the easy one. You click on the line of best fit and you're done. So the gradient's 3.826 and the intercept's 0.04, and that's easy. But for the error lines, the steep and shallow error line, you need a curve fit. So you click on the curve fit and it's showing me the wrong graph, so cancel. You have to select the graph you want first and then click on this. Aha, purple, good. and you want a linear. And if you just try a fit, it'll give you a line that's going to be on top of it. So what I do is I shift the intercept, so it's going to be hovering up there. And you click OK. So it's way up there. And it is not that one. That's the line best fit. It's this one, my manual fit. So my manual fit, how we can move this is your right-click option, fit options, enable line drag. If you don't have this, it means you need to update your Logger Pro software. Old Logger Pro software didn't have this. So you need a new version of Logger Pro software to do this little trick. Click on that, you get these little diamonds. Now you can drag one diamond. I'm going to aim for the bottom right corner of those error bars. And then drag this, and I'm aiming for the top left corner of the last set of error bars. Now, it doesn't go through each and every set of error bars because error bars are so tiny. Okay? And you might need to tweak it a bit so that eventually you're happy with it. Okay? So now I have a gradient of 4, which is a steep error line. So you can also change the color by right-click option and appearance. And it might be easier if you use red and some other color. We'll use pumpkin. So my line of it is in black and my error line is in pumpkin. So you do need one more error line. So yet again, select your graph. Make sure your graph is selected. Click on this. You have linear again. Try a new fit. Shift it down with that little button. So then when you shove it on there, it has this here. You right click options, click the line drag box, and this one we want it to be a shallow line. So I'm going to aim for the bottom right corner of the error bars there and the top left corner of the first set of error bars. Oh, I should have mentioned, if you have both set on drag, it can get really annoying because you're trying to move one and it moves the other accidentally. So what you can do is, let me get this back where it was. There it is. On the one you're already happy with, you right click to options and you turn this off. And then those diamonds disappear. So then the one line that you're toying with is the only one that's movable. So yet again, the shallow line, I would go for the bottom right error boxes on the last dot and the top left error boxes on the first dot. Okay? So my other manual fit has a shallow gradient. My line of best fit is in between, and my steep one is 4.09. I personally would also go in here and change the appearance of the other one. Since I use pumpkin for one of them, we'll go for dark blue cobalt. We'll go for cobalt for the other one. Okay. This is your second graph. Oh, by the way, you need a title. Graph options. You can, in graph options, you can give it a title. The title for graphs is usually something simple like t squared versus length. You can use lots of words if you want, but it's basically the side axis versus the bottom axis. Similarly, I should have put a title on my first graph. So right click, graph options. This one was average t versus length. So you should have a title for each graph too. All right, now let's see if we've got everything we need. We've got 3 lines. One's a line of best fit, one's a steep line, one's a shallow line. For the report, you will need to explain lots of bits and pieces. So here's a version of the 3 lines. And I personally make sure that I type up the gradients for each. Then to get your equation, we're really close to finishing the analysis, it's a long video, you need to find the differences. You want the difference between the gradients of the line of best fit in the shallow and the steep, and you want the biggest of those. In this case, the biggest one was the 0.167, which we round to 1 sig fig. Okay? Similarly, you want the differences in your intercepts of your 3 lines. So the line of best fit versus the steep line, or the line of shallow versus the line of best fit. And in this case, the larger value is the one you use. So how this works is the 3.8 is my line of best fit. The plus or minus 0.2 is the biggest difference of gradients. The 0.04 is the intercept of my line of best fit. The other 0.04 is actually the uncertainty, which was the largest difference of intercepts. So the uncertainties are always 1 sig fig. The number associated with it has the same number of decimal places. And that basically is how you figure out how to make some graphs. So your analysis section, I'll try to go nice and slow last time, would have all of your raw data with uncertainties. You explain those uncertainties. I have a screenshot, have a look at this. Then you start doing some averages, but you will need uncertainties for each of those averages. And then you have to explain how you made those uncertainties, and you probably also explain how you made the averages. Here, right here, is a sample calculation. Then you have your first graph, which we said has the constant of 2.06 and the power of 0.5 because of the relationship that's involved in the physics. So each physics relationship determines those things. Okay? And then you finally get some process data to get a straight line. But even the process data, you have to explain where the uncertainties are coming from and do a sample calculation. Then you get a straight line graph with 3 lines: line of best fit, steep, shallow. So lots of different gradients, lots of different intercepts. You look for the biggest difference between the line of best fit and shallow, and another difference between line of best fit. And finally, you end up with your equation. Now, I personally would also do a screenshot of your final Logger Pro table, and I personally would also put in a list of every single little equation that's buried inside Logger Pro. Okay? And I even included the settings. So there you go. That is how you do the analysis section. No pressure. And remember, this is a 4-page document. And that's out of 12 pages. So, not too bad. 4 out of 12. You still have plenty of pages to do other things on. I'll try to make some videos for the other things. Good luck.